Alright everybody, this is a video on explaining why the derivative of sine of x equals cosine of x. So if you ever come across different aspects of trigonometry, or I guess derivatives using trigonometry, you'll come across this kind of thing that often you have to memorize. So I'm going to try to explain why that is using this Python or Jupyter Notebook script here. So this first line here is for reloading functions in real time. I believe it works for this library. I'm using it by convention. And then here, this will actually enable me to print matplotlib inline. So I'm going to go ahead and run that. Next, I do want to import NumPy. I'm going to be using that. I'm going to import it as np, so everywhere I need to call a NumPy function, I'm just going to type np. And then I'm also going to import pi from math, and that's strictly because I'm going to be using trigonometry, so I want things related to pi. And then here I'm going to import matplotlib pyplot as plt, and this will enable me to plot things. So I'll go ahead and run that. Alright, so our first step here is just going to be simply to create data. So I'm going to be doing basically a unit circle, so I'm going to go from 0 to 2 pi, and that's what this a range is allowing me to do. So I start at 0, I go to 2 times pi, and I'm going to go in increments of 0.02. That's just to give me plenty of points. So go ahead and do that. Then I want to see what sine of x is. Well, NumPy has a sine function built into it, so I can just do the sine of x. And just to show you what my x's are and what my sine of x is, you can see here's my sine wave, and it goes from 0 to roughly 6.2, which would be 2 times pi. Alright, so that's the data we're going to start with. Okay, in order to calculate these, or in order to solve for the derivative, I could just use a basic derivative function, which I'm sure is in Python somewhere. I didn't even bother to look, but if you Google it, I'm sure there's a very simple function to call that. Instead of doing that, we are going to use a limit formula, because a limit formula is a little bit more, I'll say, basic. It gives you a little bit more grunt work to do, and by doing that, this should give us a little bit of insight to what's happening. So the limit formula is f of x plus h minus f of x, which is basically the difference in the y's with a tiny, tiny, tiny change in the x value, and then I'm dividing by that tiny value. And the reason I'm dividing by that tiny value is actually because at the bottom there's actually x plus h minus x, and those x's cancel out. So that would be the differences in the y's divided by the differences in the x's, but the x's cancel out. I'm going to select h to be a very small number. It doesn't really matter what you use here, but I'm going to use it as that. And I'm going to create a variable called f of x, or fxh would basically be this f of x plus h section of my formula. And that's going to be using NumPy sine, and I'm going to use x plus this little value. And I'm also going to have an f of fx variable, and that's just going to be my sine function. Then I'm going to create a limit, which is using the exact function I used above. So let's go ahead and run that. And now what I'm going to create is basically a little table, and I'm actually going to put it into a pandas data frame in just a moment. So just to show you what this will look like, I'm using basically a kind of a dictionary here. So where x, the value of x is equal to all my x's, the value of y is equal to my fx's, and I'm going to call something called slope. It's going to be equal to my limits. You'll see x is equal to this array, and if we scroll down, you'll see y is equal to this array, and slope is equal to this array. So you have that. Now I want to take that and make it much more useful. So I'm going to take that little dictionary, or whatever you want to call it, and put it into a data frame. And a data frame is much easier to work with. So here I'm going to import pandas as pd. I'll call pd.dataframe, and I'll import this little dictionary I made. And this makes my data look like this, which is much more friendly. So basically you have your index over here, it starts with 0. I have my x values that again start with 0, and they go by 0.02. I have my y output, and then I have the slope at each one of those locations. Okay, so now what I'm going to do is actually plot first my actual sine graph, so my original data. Then I'm going to plot my x value with that new slope. which is going to be right here. And I called it with limit, but I could have pulled from the table as well, which I'll do later. This little character here, R, and B just stands for red and blue. So you'll see it plotted together. Red is my original sine wave, and blue is the derivative, essentially, the limit of this function. You notice it's actually a cosine wave. So if I go back in and I plot instead the cosine of x, I can see that plotted right there. And I'm going to actually make that blue just so it looks the same there. So see, those two blue functions there are identical. So we just did basically the limit of sine, or the derivative of sine, to produce this cosine function. Well, getting a little bit more, let's go backwards first. So in addition, the derivative of cosine is actually negative sine. It doesn't just go backwards, it goes backwards and kind of inverts. So I'm going to do the same thing here, but instead of using sine for my f of xh and f of x, I'm going to use cosine. So same exact thing, using that same exact formula here. Go ahead and run it. I'm going to create that same little array, but instead I'm going to have cosine as my input instead of sine. Go ahead and run it. I create my data frame and I check it out, and you'll notice here is my slope. Okay, so I start with x, I have the y, and I have the slope. And additionally, if you know anything about sine and cosine, sines start at 0. If you notice, sine starts here. The cosine starts at 1. Well, if I go up to my data, my y value of the sine was 0, and my cosine value down here started at 1. So everything's looking pretty well there. And I can go ahead and plot those. Red is my original, and now blue is negative sine. You can see that by plotting here negative sine, and you'll see they're identical. So we've gotten those values. Now let's see what's actually kind of happening in the background. So this will take a little bit. First, I'm going to see how many data points I have. I have 315 data points. Okay, I'm going to use that here. And what I'm going to do is import this matplotlib animation, and there's this func animation function. I'm additionally going to import this IPython stuff here, particularly display. I don't even think I used clear output. I copy and pasted that. What I'm going to do is the exact same information. We're going to deal with sine here. So we're doing the first section we started with. Do every single step that we've done. The difference is here I'm going to actually animate the points as I put them in, as I calculate the derivative, or as I calculate the limit. I'm going to graph that point, and you'll actually see it kind of unfold. So just to show you, if we go up to sine, at this point I have a slope of 1, so I would put a dot here at 1. So x equals 0, y would be 1. As you progress, this starts to become less steep until you hit 0 right here. And if you go to the coordinated spot on cosine, you'll see at that x point the y value is 0. And again, you continue going, and it starts getting less negative, I'll say, and it starts kind of decreasing in its steepness going down, and then it again branches off to a slope of 0 here. And if you go up from that point, you'll see again it flashes back at 0. So we're going to actually see this take place. Okay, so let's go down. This will take just a moment to load, so bear with it. But I also did draw the line at 0. So as you see this, you'll see the plot of sine. You will see a plot of a line at 0. And then you'll see the scatter plot kind of appear piece by piece. So bear with it just for a moment. And of course, if you want to use this code, just you'll have to type it from the screen, but you're more than welcome to use it. All right, so here it goes. So here's our original sine plot. Here's our 0 line. You'll see the points appearing. Basically, you had a slope of 1 at the start. You plotted 1. That slope decreases. It decreases, 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 decreases. At this point, it's going to cross the 0 line, and there it goes. And it all of a sudden becomes negative. And it becomes increasingly negative, increasingly negative, increasingly negative, until you hit right about here. At this point, the slope then starts to become less negative. Still a negative slope, but it's kind of flattening out as we go down. And again, it's going to all of a sudden cross at 0 right as you hit this x value. And here it comes. At this point, you would have a slope of 0, and then all of a sudden the slope would become increasingly positive again, and it would repeat that pattern. And if you notice, what we've gotten here now is the cosine slope, or the cosine graph. So that's exactly why this exists, and that'll just continue as it goes around. So whenever you get to these problems of sine of x, the derivative of sine of x equals cosine of x, you can resort back to this and think, why is that the case? And again, for the same reasoning, when you get to why is the derivative of cosine of x negative sine of x, it's the same exact reasoning. You just have to think of it in a slightly different manner. Anyway, I hope this was helpful.